So in this video, we're going to show how to use the disk method for volumes of revolution to find the general formula for the volume of a cone. So here's a cone of radius r and height h, and what we want to remember from geometry is that the volume of a cone is equal to 1/3 pi r squared h. And what we want to show is that using volumes of revolution and the disk method, we can actually come up with this formula from scratch. And the idea is if we have a cone of height h and radius r, we can orient that cone like we have here, where the vertex of the cone is at the origin. And we put the height of the cone along the horizontal or x-axis. And we orient the radius so that it's parallel to the y-axis. And if we do that, the x-coordinate right here would be h. It would correspond to the height of the cone. And because r is now the height here, r would correspond to the height with respect to the y-axis. So this line right here, which represents a cross-section of the cone in the xy plane, the ordered pair right here would be input height, output radius. So that's the first thing I want to recognize. And then I want to recognize that I can actually come up with the equation of this line. So remember, a line has the equation y equals mx plus b, but b is just the y-intercept, which in this case, because of how I oriented the cone, is 0. So we just need y equals mx, where m is the slope of the line. And remember that slope is just rise divided by run. So in this case, the rise over run is just going to be r over h, right? If we thought about it in terms of ordered pairs, we would get r minus 0 over h minus the x-coordinate here is 0. It's just r over h. So rise over run is just going to be radius over height. So I can actually describe the equation of this line here as y equals radius over height, that's the slope, times x. So there's my mx plus b form of the equation of a line. So what I want to recognize is that to generate the cone that I have here, all I need to do is take this line and rotate it around the x-axis, and then the cone will be the volume of revolution I get when I revolve this line, y equals r over hx, around the x-axis. So to do that, to get the volume then of that cone, I just need to remember how to do a volume using the disk method and a horizontal axis of revolution. The formula is here for your convenience. I'm just going to step through it. So we would say, hey, the volume of my cone that I've taken from here and oriented into the xy plane nicely is going to be pi times the integral from, I'm integrating with respect to the x-axis. So if I draw in a representative rectangle like this, I want to recognize that these are dx slices, and my radii are going to be the y-coordinates on the line, the heights of that line. So it's going to be pi times the radius squared. My radii are given by my y-coordinates. So pi y squared h, where h is the distance across the bottom of the representative rectangle. So my h's are just dx's. And I'm going to be integrating from 0 to h on the x-axis. But I have to describe my radii, my y's, as functions of x's. So as a function of x, y is equal to r over h times x. So I want to recognize I really need pi from 0 to h times r over h x all squared dx. And again, recognizing that pi times the radius squared is the area of the cross-sectional circles of our disk, and then the dx is just the height of each of those cross-sectional disk or cylinders. So I can simplify things a little bit here. I want to recognize that r squared over h squared is a constant and can be factored out front. So I can factor an r squared h squared out with the pi. and it's times the integral from 0 to h of x squared dx. And now I'm ready to integrate. So I get r squared pi over h squared. The antiderivative of x squared is just 1/3 x cubed, and I'm evaluating from 0 to h. When I plug in the lower bound of integration, it would zero out the x, so I only need to plug in the upper bound of integration, the h. So I wind up with r squared pi over h squared times 1/3 h cubed. And h squared will go into h cubed h times. So what am I left with? I'm left with the 1/3 right here. 1/3. I'm left with the r. So I'm left with the pi r squared. 1/3 pi r squared times the h that's left there. And there's the classic formula for the volume of a cone that you learned in geometry.